Hello everyone, welcome to my presentation on unit testing. My name is Thomas Antony, and today I will guide you through the fundamental of unit testing, its important technique and best practices and more. Unit testing is often underestimated, but it plays a pivotal role in a software development lifecycle. This presentation is designed to provide a comprehensive understanding whether you are new to testing or looking to refine your skill. Let's get started. So the introduction, unit testing is an aspect of software development. It ensures the individual components of a program perform correctly, allowing developers to spot and resolve issues efficiently, maintain high quality code, and integrate different parts seamlessly. First, let's define what unit testing is. Unit testing involves testing the smallest testable parts of an application, like functions or method in a isolation. By doing this, we can ensure that every component behave as expected before integrating into a larger system. Think of the unit testing as checking each brick of a building before a construction begins. If the individual bricks are solid, um, you are more likely to have stronger structure. Or similarly, like unit testing helps prevent bugs early, ensuring the foundation of your software is solid. Imagine a simple application with the login features. Unit test can check if the valid password function correctly identify valid and invalid passwords. If this function works perfectly, we can focus on testing other parts like database interaction or UI element later. I think it's a great tool to use as unit testing. Let's talk about the importance of unit testing. Uh, the importance of unit testing is it detects bugs early in the development process, reduce cost and efforts, um, encourages cleaner or more maintainable code, um, acts as a executable documentation, clarifying how code behaves. So the importance of unit testings are the code correctness and reliability. Unit testing ensures that each part of your code does what it's supposed to do. Like this is particularly important in critical applications like financial systems or healthcare software, where even minor errors can have significant consequences. Or like, and the second is faster debugging. Um, with unit testing in place, finding and fixing bugs became easier instead of shifting through the entire code base. You can identify the exact function or method causing the issue. And the third one is it increases productivity. So how do I say? While like unit testing requires an upfront investment of time, it saves times in a long run by reducing debugging and maintaining maintenance efforts. I'll give you a real world example. Like companies like Google and Microsoft prioritize unit testing because uh, it allows them to deploy features confidently and maintain robust, scalable systems. So it detects bugs early in the development process, reducing cost and efforts, and encourages cleaner, more maintainable code, and act as a executable documentation clarifying how code behaves. Um, so the three most important things are code correctness and reliability, foster debugging, and it also increases productivity, which saves time. So let's talk about why unit testing. Unit testing enhances code quality and accelerates development and boosts productivity. Validates code accuracy and dependability, and simplify code maintenance and refactoring. And instills confidence in changes, supports agile development methods, development methodologies. Sorry. So why unit testing? I let's deep deeper into the benefits of unit testings. The first thing is it's fascinating coding, refactoring, and maintenance. So software involves, like, over time you may need to refactor your code to improve performance, adapt to new requirements, or clean up technical debt. Unit testing act as a safety net during these changes. Uh, they ensure um, that original functionality is intact even after modification. So building, and the second one is building confidence in code changes. Have you ever hesitated to modify a critical part of your code base, fearing it like it might break something? Unit testing eliminate that kind of fears. By running automated tests, you can confidently make changes, knowing that any issues can be caught immediately. So the first one we discussed was facilitating coding, refactoring, and maintenance, and the second one is building confidence in code changes, and the last one is supporting agile developments. Agile emphasizes interactive developments. Unit testings align perfectly with this approach. Test driven developments, or TDD, which we'll discuss like shortly, further enhance the agility of your software development process. So uh, sorry, these are the three important things in the slides: facilitating code, refactoring, and maintenance, and building confidence in code changes, and supporting agile developments. This is why we use unit testing mainly for. So let's go to the next slide. Ensuring code correctness and reliability. So unit testing is a crucial role aspect of software development that helps to improve code quality and speed up developments and increase team productivity. Uh, it offers many benefits like ensuring code correctness, reliability, making code refactoring and maintenance easier. Uh, so building confidence in code changes and supporting agile practice by using unit testing I think developers can save time and they can avoid like errors, and ultimately you can create a better software. um, Ensuring code correctness in reality is very beneficial for using unit testing. That's why it's very important in this slide, one of the important slide. um, we'll go to the next slide. uh, Facilitating code refactoring and maintenance. So unit tests serve as a safety net, so enabling developers to refine code without fear of introducing new issues. They also provide insight into code functionality or collaboration and understanding. Uh, this slide and the other side are almost similar, talking similar itself. This slide is mainly talking about the crucial aspects of software. Like it helps code quality and speed up developments. But here, this slide it's actually telling like we can use unit testing like without worrying about if you're gonna mess up your code or not, and also collaborations and improve collaboration and understanding. Mm, let's go to the next slide. Building confidence in code changes. So next slide is about building confidence in code changes. As automated tests such as those in CI or CD pipeline gives like developers instant feedback. This supports rapid iterations and foster a culture of innovation. So this slide is mainly talking about how things how how confident can be when we do code changes. So like I said, it's automate tests such as those in CI and CD pipelines. It also give developers an instant feedback, which is very important, which is very helpful also. This supports rapid iteration, iteration. Sorry for the iteration, and foster a culture of innovation. Um, so the next slide is about supporting agiles. It is very similar to the one we did. It's like one of the main important helpful thing in unit testing. Sorry. Unit testing aligns with the agile principles. It by allowing incremental developments or test driven developments or TDD. Further enhance agility through iterative coding cycles. So we kind of change. Yeah, so this slide is mainly talking about how agile development can help test driven development. Yeah. And the next slide is about stubbing and mocking. These techniques are isolate code units by stimulating dependencies. It's like mocking mimics real object behaviors for interaction verification. Stubbing provides predefined responses for consistent testing. uh, I think in this slide what stubbing means, like when testing, I would say stubbing and mocking are like essential tool for effective unit testing. So when stubbing a function that depends on an external API, you don't when stubbing, like you don't want to you don't want to you don't want to actually call that API every time you run your tests. um, a stub replaced the real API with the predefined response, which is very helpful. And a mocking are more advanced, that they are not only stimulate behaviors of real objects, but also like verifies that interaction with those objects happen as expected. So for example, consider a function that fetches weather data from an API. Instead of making a real data from an API, instead of making a real data from an API, instead of making a real API calls, you can mock the API and test whether your function handles a responses and error correctly. So the tips like uses libraries like Mojito for Java or unittest.mock for Python to implement stubs and mock efficiently. So for this, mainly stubbing and mocking are very important in unit testings. These techniques isolate code and units by stimulating dependencies, and mocking mimics real object behaviors for interaction verification, and stubbing provide predefined responses for consistent testings. So it's very important. And the next slide is about test driven development. Test driven development, also you can say TDD if you're really good if you're like a software engineering majors. Sorry. Test driven developments involves writing tests before code. It focus on desired behaviors. So like there are steps to do testing driven developments. It's writing fault tests, and develop a code to pass them, then refine. Those are the steps. And the benefits of enhanced quality, faster feedbacks, and enhanced quality, and throw coverage, and safer refactoring. So test driven development, or TDD, flips the traditional approach. Instead of writing the code first and test later, you begin testing. So, like, if you want to try that, you can write a test that capture the desired behavior of a function and just run the test. It will fail because of the function doesn't exist yet, but write just enough code to make the test pass, and refactor like the code while ensuring the test still passes. And the benefits are like it forces you to think about sorry it forces you to think about functionality before implementation. It also ensures through test coverage, like it supports cleaner and modular code designs. It's very important. So test driven development, or TDD, involves writing tests before code, and also it focuses on desired behaviors. Writing failing tests, develop code to pass them, then refine. The benefits are enhanced quality, faster feedback, and through coverages and safer refactoring. Um, I would say it's very important. One of the important side also. And the difference between mocks and stubbing. We just talked about mocks and stuff in the last previous slides. Uh, Mocks stimulate real object to verify interactions. Stubs provide predefined responses to ensure predictable behaviors. And both techniques support isolated and effective testing. So this slide, the difference between mocks and stubs, like it's easy to confuse mocks and stubs, but they serve distinct purposes. Like mock focus on interactions. For example, does your function calls the correct method on an object? So and also stub is provide consistent predefined response to and isolate the unit under a test. So in practical, like in real world, you might use mock and stub in a same test suits to handle different scenarios. Like remember, the goal is to isolate the unit tested as much as possible. So these are the difference between mocks and stubs. So let's go for good units. So good units testings. Effectively, unit testings have these kind of qualities, like it isolates test only one units, repeatable, consistent results, fast and quick feedbacks, self-validating, so the results are going to be clear, focused. It tests like one thing at a time, and readable. So like it's when you have good unit testings, it's very easy to read, it's very easy to understand, It's very easy, like when you work in a team, it's very important, like you and your team to understand everything really easily. So having a good unit testing is or readable. So good unit testing practices, like writing a good unit test is an art. So here are like, so it can make your test effective. Isolated tests, like it ensures the tests don't depend on external systems or other parts. uh, Repeatable tests, your test should yield the same results regardless of the environment. Readable tests, return test names and comments that explain their purpose clearly. This can make it easier for others and your future self to understand them. For example, instead of naming a test function 1, name it like a test valid password return true. It can make it much more formal and much cleaner. So, and the conclusion is going to be, this is going to be a wrap up. Crafting a well designed unit test ensures software reliability and quality. By following best practices, and developers can improve code improves, foster collaboration, and build confidence in their work. Its effective unit testing is an investment in robust software. So To wrap up, unit testing is not just a technical process, it's a mindset. It encourages developers to think critically about their code, leading to more robust and maintainable software. By following the best practices and leverages technicals like TD, stubbing, and mocking, you can create reliable unit testings that significantly improve your developments. Final out. Remember that the effort you invest in writing good tests pays off in the form of higher quality software, reducing bugs, and more confidence in development teams. So thank you for your explanation. Thank you for your attention, and have a good day.